Okay. Now, what does that mean? What do you mean by what do you mean by equivalence? What is that? Now, you have to check the transition table for this state transition table. Now, tell me, the first step, the first process, what do you have to do over here for calculating the equivalence is that you have to make two set of states. Which are the set of states? One is non non-final states, and the other one is
Final state.
final state, or there might be one or two final states also. So we are going to check one example on more one or two or three number of final states. Okay. So this is the for equivalence you have to first make two groups or two sets. One set will contain the non-final states, and other set will contain the final states. Now I'm going to write it down. Non-final states are this here: A, B, C, and D. Okay. A is the initial state, means it is not a final state. Then I have other states B, C, and D. Okay. And my final state is E. So this is what my first equivalence, that says it is a zero equivalence. This is called as the zero equivalence. First step is grouping the non-final state and final states. This is called as zero equivalence. Okay, is this clear?
Yes, ma'am.
Now next one, you have one equivalence.
Excuse me, ma'am.
Yes.
Ma'am, I was disconnected for a while. Can you please repeat?
Okay. So I'll just repeat that. So this DFA is given to you. In this DFA, how many states are there? There are 5 states here: A, B, C, D, and E. A is my initial state and E is my final state. I have also given the transitions. The transitions are also shown in the DFA. Okay. Now, for step number 1 for minimization of a DFA is to construct a state transition table. Okay. So we have
Yeah, ma'am.
constructed.
That I understood from
Okay.
step 2, ma'am.
Okay, so okay, I'll just continue with this. So we make this state transition table. Then comes our step number 2. Step number 2 is called as equivalence. What do you have to do in equivalence is that you have to make two groups basically. Okay, your first set, it will contain the non-final states, and your second set will contain the final states. Okay. Now looking at the table or the DFA, we know that A, B, C, D are the non-final states. They are not the final states, right? And the other group is E. E is the final state. We know that. So this is called as a zero equivalence. So always remember that for zero equivalence, or the first step in step number 2 is that you have to make two groups of non-final states and final states. Okay, is this clear?
Yes, ma'am.
Okay. Now comes our one equivalence. How do we do that? Okay, one equivalence. Now let us have a look at this set. I will just check my non-final states. Okay, checking the non-final states. We will write here. Check the non-final states. Okay. Now, how many states are there? We have A, B, C, and D. We have 4 states. Now you have to check them one by one in this state transition table. Okay. Now you check this 2 states first. Okay. So I will check A, B first. Okay. A comma B first. Okay. Now check this A and B, these 2 states, what values are they giving for 0 and 1? A on 0. A gives 0 to B, right? And A gives 1 to C.
Are giving B, ma'am.
What?
Both A and B on 0 are giving B.
Yes. And B on 0 is giving, both are giving B. Okay, both are giving B. Okay, that's fine. But initially, what you have to do, you have to start preparing a set here. So A is my initial state. So we always have to include that state. We cannot eliminate that. So I am writing A as it is, and then I am finding the pairs of A, B of these two states. So from these two states, we can see that B is common. Okay. But still, let's proceed with some other state. Now you can check for AC. Check for AC. Okay, because these are present in one group, right? One set. That's why we will check for AC again. Now what happens in AC? We have B and C both are there, right? Is this clear? A on 0 gives B. A on 1 gives me C. C on 0 gives me B, and C on 1 gives me C, right? Both A and C are giving BC. So we'll write here, both AC are giving, both AC are giving BC for 0 and 1. Yes, is this clear?
Yes, ma'am.
So then I can write BC in this set. I can write BC in this set. So always remember that when you have to calculate the one equivalence, you have to write only those values which are common, and and it should be common for both the inputs. For 0 also and for 1 also, both the values should be same. Only then you can include them in one group or in one set. Okay. First, previously we saw AB. For AB, we just had B common. Both were giving B, but that was only for one input 0. For one, they were giving different values. So that's not acceptable. Then we have had a look on the other pair, AC. Now AC is giving B and C for both the inputs 0 and 1. Therefore, we can say that both B and C can be included in our group. Okay, this is what we are doing. Now, if you want to see, just check AD also. Okay, AD also. What's happening in AD now? Tell me anything common? Both the values should be common. Okay, the main motive over here is that both the values should be common for 0 and 1 for both the states AD. A on 0 is giving me B. D on 0 is giving me B. Okay, B is there. A on 1 is giving me C, but D on 1 is giving me E. So that is not acceptable, right? So I cannot write here those states. Okay, I cannot write D or something. Now let's have a look at BC. Other one, BC and BD also we can compute, right? Check BC. BC, anything common? No. So not acceptable. Sorry. Yeah, BC not common. Now BD, check for BD. For BD also, B on 0 is giving me B, B on 1 is giving me D. D on 0 is giving me B, and D on 1 is giving me E. So that is also not acceptable. Now I will check other pair, that is CD. I will check for CD now. Okay, check for CD. CD also nothing is, both the inputs are not common. Only B is common among them. So that is also not acceptable. Okay, so we can say that D cannot be included in this group. Instead, we will put or we will keep D in some other set. We will create a separate set for D. And we already have E. Is this clear? Both the inputs, the states for both the input 0 and 1 should be same. Okay. Now we will compute two equivalence. Okay, two equivalence. Okay, now check check the pairs. Which pairs I have to consider for two equivalence here? Either AB, AC or BC, right? I have two pairs now. So either AB, BC and AC. I have to check these two pairs. Okay, AB, check for A and B. Are they giving some common values? No, they are not giving. BC, they are also not giving same values. AC, yes, AC is giving the same value, right? AC is giving me the same value, isn't it?
Yes, ma'am.
So what do we have to do here? It means I can include what? I can include AC in one set, right? So I will create one more set. I will just include AC here. I will put B in separate set, D in separate set, and E also is my final state. That's why it is in my separate group or separate set. Now I will compute three equivalents. Okay, what's happening in three equivalence is, again we have to check the same process. So it is observed that they are always it's two equivalents and three equivalents gives the same results, but we have to just check and confirm it. So they are giving the same values A, C, B, D, and E. So this is our final set of final values of three equivalents. Now what can we do over here? We have to construct a DFA now. So how many states there will be? 1, 2, 3, and 4 states now. So I have reduced that from 5 states to 4 states. Okay, 5 states to 4 states. I have reduced that. Okay, now just try to make a DFA. So I will DFA A is my initial state. I know that A is my initial state. Therefore, A is there, but along with A, I also have C. So I will not leave that. I will write C also, and that C will also become my initial state now. Now I'll write B here, D here, and then E is my final state. Okay, now tell me the values. Wow. ACB, check the state transition table. ACB, it gives what? When does it give B? Check for AC. AC is giving B or on 0, right? From the transition table, we know that A and C. A is giving B on which value? Which transition? 0, right? A gives 0 to B, right? Similarly, C gives 0 to B. That's why we can show a transition like this, 0. Now check other values. A gives 1 to C and C also gives 1 to C. What a coincidence, isn't it? Both A and C are giving the same values BC, na? We know that from the table. So A on 1 is giving C and C on 1 is giving C. So it means 1 goes to itself. Now B gives 0 to B. Okay, so I'll draw that. B gives 0 to B. B gives 1 to D. So I'll show that also. C gives 0 to B. Okay, C gives 0 to B. That's already there. C gives 1 to C. That also I have already shown it. D gives 0 to B. Okay, now D gives 0 to B. D gives 1 to E. So D is giving 1 to E. Then E is giving 0 to B. E is giving, sorry, E is giving what? E is giving 0 to B. E is giving 0 to B. Similarly, E is giving 1 to C. So it will go in this state. So this is my reduced minimized DFA. Okay, this is my minimized DFA. Is this clear, guys?
Yes, ma'am.
You have to practice a lot. If you have any doubts, you can just reach out to me. Okay, so this is your minimized DFA. This is our final solution. This is our minimized DFA. Now just note it down, all the process, all the steps. Okay, then we can take other example. Write down step number 1, step number 2.
Ma'am,
Yes.
ma'am, in first equivalence, why we include AB in the set? We don't have any common in it.
Why didn't we include AB?
Why should we include AB?
I'm not getting your question. What happened?
मैम फर्स्ट सेट में फर्स्ट इक्विवेलेंस जब हमने फाइंड किया तो मैम ए बी सी तो सेम सेट में रखा जबकि ए और बी में तो कोई इनपुट कॉमन नहीं है सिर्फ बी कॉमन है बाकी के सब
A और B क्यों लिखा? ये क्वेश्चन है.
यस मैम
सी ए इसलिए लिखा क्योंकि ए इनिशियल स्टेट है और इनिशियल स्टेट हमको लेना ही पड़ेगा. ओके, आइदर वो कहीं पे हो या ना हो, उसका वैल्यू कॉमन हो या ना हो, बट ए इनिशियल स्टेट, इट्स द इनिशियल स्टेट ना, दैट्स व्हाई वी हैव written ए एज इट इज. ओके, इज दिस
Yes,
क्लियर?
ma'am. Yes,
इसलिए
ma'am.
ए को लिखा. एंड नाउ व्हेन आई चेक द पेयर ए बी दे आर नॉट गिविंग एनी कॉमन आंसर, सो वी हैव नॉट टेक कंसिडर्ड दैट. तो बट ए सी तो दे रहा है, राइट? ए सी इज गिविंग मी बी सी, राइट? दोनों ने बी सी दिया है और ए को हमको लिखना ही पड़ा क्योंकि वो इनिशियल स्टेट था, और सी हमको बी सी दे रहा है, तो इसका मतलब वो दोनों बी और सी हम उसमें ले सकते हैं. ओके,
Ma'am, 1 second, please.
A is my initial state, so A I have to write A, right? That is understood.
Yes, ma'am. Yes,
Now
ma'am.
I will check the pairs. What were the pairs? It were AB, AC or AD, right? So first I have checked for AB. दोनों को check करना है, A और B को. Okay. Now A 0 दे रहा है B को, B 0 दे रहा है B को. ठीक है. A 1 दे रहा है C को और B 1 दे रहा है D को. बट यहाँ पे दोनों का वैल्यू 1 को, दोनों का वैल्यू इज डिफरेंट, राइट? दे आर नॉट द सेम.
Yes,
तो
ma'am.
फिर ओके, तो फिर ये पेयर हमने कंसिडर नहीं किया. फिर हम दूसरा पेयर कंसिडर करेंगे ए सी को. तो ए और सी को हमने कंसिडर किया, और यहाँ पे क्या हुआ? यहाँ पे ए 0 दे रहा है बी को, ए 1 दे रहा है सी को. सिमिलरली सी 0 दे रहा है बी को और सी 1 दे रहा है सी को. तो ए और सी तो है ही, हमको पता है वो, राइट? और वो वैल्यूज क्या दे रहा है? बी सी दे रहा है. तो बी भी है और सी भी है, राइट?
Yes, ma'am.
ओके, ठीक है, फिर से देखते हैं. नाउ
No, ma'am, I got it.
ओके, ओके, सो राइट डाउन द स्टेप्स. Okay, now write down 2 equivalents and 3 equivalents. Okay, so just write down 2 equivalents and 3 equivalents, and after 5 minutes we will start with our second example. Okay, finished all of you?
Yes, ma'am.
Okay, so now let's take some other example. Okay, so write down a question. Minimize the given GFA. Here our next question will be minimize or the given GFA. So now we will take multiple set, okay, multiple states over here, and there is one more question here, but that I will include in tutorial. That would be better for you to understand and practice. Okay, I want all of you to practice it. Okay, so we have second question over here is, okay, minimize the following DFA. Minimize the following DFA. Okay, this DFA is given to you. Okay, you have A, B. A is my initial state. Now here we are taking more than one final states. Okay, just observe that there can be more than one final states. Okay, okay. Just take this DFA. This DFA is given to us. We have to minimize the following DFA. So we know that step number 1 is to make a state transition table. So I will make that. I'll write the states A, B, C, D, and E. And one more state I have here, that is F. And for the inputs, 0 and 1. Okay. Write down the values here now. Okay. What are the values here? Write it down. It is BC. B on 0 is A, B on 1 is D. Similarly, okay, now show this. This arrow indicates that A is the initial state. Similarly, circle this C. C is the final state. Similarly, D is also the final state, so circle it. E is also the final state, so I'll circle that also. And then I'm going to write all the values of C, D, and E. Write it down, guys. Okay, these are all the values. Again, E, F, and then over here, F is giving F on 0, F is giving 1 on F. Is this clear? This is your step number 1. Yeah, yes or no?
Yes, ma'am.
Okay, now our step number 2. I know it's getting a little difficult, but try to understand, okay? And try to practice as many sums or questions as possible. And before your UT1, I'm also going to give you certain questions for practice. Do that very well. Okay, now step number 2. Step number 2 is what? Step number 2 is computing or calculating the, write it down. It is equivalence. In that, I'm going to write my first equivalence, that is zero equivalence. Zero equivalence says that I have to make two groups of non-final states and final states. So I'm going to write here all the non-final states, and those are A, B, and F, right? And my final states are C, D, and E, right? These are my final states. So write it down. Now next one is I have to compute one equivalence. I have to write one equivalence. So I will write that one equivalence. Now you have this values. Now always remember that whenever you want to compute one equivalence or two equivalence, etc., you always have to refer the set which is present. Okay, for one equivalence you will refer this set of zero equivalence. For two equivalence you will refer the set of one equivalence, like that. Okay, now for one equivalence we know that there are how many pairs. We always have to include a, so a is by default present. Okay, so write it down. A is already there. Now I'm going to check how many pairs AB and AF. I'm going to check for AB, AF and BF also, right? Check for AB. A on 0 is giving me B. A on 1 is giving me C. B on 0 is giving me A. And B on 1 is giving me D. That is not acceptable. A on 0 is giving me B. A on 1 is giving me C. Similarly, F on 0 is giving me F and F on 1 is giving me F. This is also not acceptable. Not acceptable. Write it down. Now check for BF. Okay, B and F. Is this accepted, guys?
No, ma'am.
Check the values of B. B on 0 is giving A. B on 1 is giving D. Similarly, F on 0 is giving F. F on 1 is giving F. Not accepted. Write it down. Not accepted here. Okay, now what? Now what to do? It means what? Yeah, are we going
all three in different groups?
Are we going in a proper way? Just check it again. Okay, check it again. Okay, check for AB and tell me. We might get something wrong because
No,
something has to
I
be
think
there.
it should be
Yes.
accepted.
Which
AB.
AB? Why?
When because AB, like for 0, it's B and B and A belong in the same set, ABF.
Yes.
And then
Yes.
for 1, that's C and C and D belong in the same set, which is the requirement
Yes.
for.
So B is there. So we know that. So A and B has to be there in the same set. Okay. Now, similarly, as you said that C, D, and E are in the same set, but F is not belonging anywhere. So I will prepare a new set for F, and I will include C, D, and E in same set like this. Now I will compute two equivalents. Values for two equivalents, are they similar to one equivalence here? When you try to do this, it is giving me the same result, right? I'm having the pair AB and AB are already there in the same set of same group. Okay, so I'll write AB as it is, and F is also there in an individual set, and CD are together. This is my two equivalents. Now you have to construct a state transition table. How do we do that? For state transition table, you have to, okay, write it down. 0, 1. Okay, A, B. Here you have F. Similarly, here you have C, D, and E, where A, B is my initial state now, and C, D, E are my final state. From table, from the state table, A and B return values A on 0 is giving 0. Okay. And D on 0 is giving A on 1 is similarly B on 1 is giving D. That's why now F we know that it is already FF. So I'm writing FF as it is. Now D, C on E, everywhere it is C, D, and again this is my state transition table. Now I have to prepare a transition diagram. State I have 3 states here. So I'm going to show that. First state is AB, which is my initial state. Then my next state O, and final state is C, but E is also here. I'll write E also here. Why? Because they are in one group now. So whenever I have something, I'll have to other member. Or then one is giving. Then F on 0 is giving and giving E. So it is going to itself. And C, D, E 1 is giving to F. It's giving 1 to F. So this is my minimized DFA. So I'm going to write that this is my minimized DFA, right? So write it down, all the steps, okay, and complete it. Okay, try to complete that. So now just draw this DFA. This is our NFA to DFA. Have we seen that or no?
Yes,
If
ma'am, we have
not,
seen.
then yeah, we have seen. Okay, I think we had taken 2 examples on that. Okay, so guys, in the next lecture, we will start with regular expressions. Okay, so this is done, and next lecture, we will start with our next unit, that is regular expressions. Okay, now should I stop sharing my screen? Let me take your attendance. Okay, I have downloaded your attendance, guys. Thank you. You can leave the meeting.
Thank you, ma'am.
Yeah, bye. Take care.
Bye, ma'am.
Bye.